Hi, my name is Sharon Acoff-Sledge. I am a second-year PhD student in curriculum and instruction at Alabama A&M University, and my concentration is in mathematics. I am currently a math teacher at Liberty Middle School in Madison, Alabama, and this year I teach Accelerated Math 8, which is Algebra 1, and I am also the math team coach for 8th grade. My instructional context, again, this is an accelerated 8 class, Algebra 1. This particular class has the most variety in performance levels. I have students who are that perform at a high school level, all the way down to students who struggle to make a C. And that's unusual for an accelerated class, but this particular class has those issues. I have a student in the class that has an IEP for behavior and academic performance, and I have a student with a 504 because she needs accommodations for lack of focus, and then it's everything in between. Some of my students can work independently while some cannot. I have to pull them into small group. And there are some that sometimes I have to pull them in for individual lessons, one-on-one. The content area for this problem of practice is on linear equations and linear relationships, especially relationships. Students can solve linear equations, but sometimes struggle with the concept of inverse operations. So when we get into multi-step, they may have an issue solving, or even when we have situations where a linear equation is not in slope-intercept form, and I say solve for y so that you can, or put this equation into slope-intercept form, or I may have to break it down and say what you need to do is solve for y. Some students have problems with that conceptually because they have problems with inverse operations when solving equations. And connecting multiple representations where we're in slope-intercept form or standard or point slope. They have problems connecting, like they will always say the slope is the number in front of x. And we have to clarify that it's the number in front of x when your equation is in slope-intercept form. It may be somewhere else if it's in another format. So as a classroom teacher, I do whole group, I do small group, and I do individual. To monitor my students' growth and their progress, I use both formative and summative assessments. My formative assessments sometimes is by observation. And students need to they sometimes have problems connecting multiple representations, like if it's a table or a graph or a real life situation, they may have problems recognizing that is a linear relationship. So far as the mathematics difficulty, the primary mathematics difficulty that I have identified is that my students demonstrate inconsistent conceptual understanding of linear equations, especially when they're doing independent work. They can demonstrate understanding while I'm whole group teaching, and then when I finally release them to work independently, that's where the struggle really shows. They may misunderstand the meaning of the variables. What's your y-intercept? The y-intercept is on the y-axis, the x-intercept. Vertical and horizontal lines, they have problems with those. Treating the equal sign as a signal to perform an operation rather than as a statement of equivalence. Not understanding, again, inverse operations and why they work, why we use them. And students often have problems understanding slope and y-intercept in real world context. So we try to teach y-intercept as the initial value. So if I say someone pays a $10 fee plus $3 per hour, we need them to understand that the $10 is the initial value, which is the y-intercept, and the $10 per hour is my constant change, which is the slope. So we try to get them to understand that. my draft problem of practice. So in my 8th grade accelerated math class, this particular class, several students, they struggle to develop and sustain conceptual understanding of linear equations and relationships. And again, their independent work reveals that struggle. They may answer questions when I'm doing a formative assessment or checking for understanding. They may be able to answer questions in that context. But then when we turn them loose individually, those misconceptions come to the forefront. Um, and this misconception leads to problems with assignment completion. Students get frustrated and they decide, okay, I can't do this assignment. And so they give up or they turn in an incomplete assignment if they turn it in at all. They lose focus because they're no longer interested because it's a struggle. Algebra 1 is, let me pause for. The significance of this is that Algebra 1 is a gateway to every higher math course. And being able to understand equations and to solve them that's as basic to higher level math and higher level algebra, geometry. It's just as basic as 1+1 = 2 is to a student's conceptual understanding of addition. So that's why I picked this particular topic. Students tend to, when they don't understand something conceptually, they tend to memorize procedures without an understanding of why they use those procedures, why that procedure works. This often leads to struggles with geometry and higher level algebra. And I picked this topic because I tutor a lot of geometry students who came from our school who struggle with linear equations, and it causes a struggle with geometry. And it leads to decreased confidence in mathematics. And research shows that algebra misconceptions are persistent and can interfere with future learning if it's not addressed early. Just anecdotally, students who struggle with multiplication, I ask them about their 3rd grade experience because that's when they do the switch from repeated addition to understanding multiplication as a shortcut to repeated addition. I see some students still repeating addition even in accelerated courses, or they need a calculator. And so that's a misconception that occurred in 3rd grade, a conceptual understanding that was not developed in 3rd grade, and it pervades through every math course until someone stops and does intervention, which we often have to do in middle school. And so students who do not consistently engage in practice and feedback cycles, they're less likely to correct misunderstandings over time. So it's critical not only for immediate classroom success, but also for students' long-term success in mathematics. And in closing, overall, this problem of practice highlights the need to better understand how conceptual understandings develop and how instructional supports can promote independent mathematical reasoning. I look forward to refining this problem further through feedback and continued research. Thank you for your time.